Hi.
Can you hear me?
Yes, we can.
Yes, now we can hear you. Please leave, Noori, please leave your microphone unmuted. Do not mute your microphone because we're listening to the trainers through that.
Okay, so welcome, you guys all, also the online audience from different countries around Asia. Welcome to our session today. Today we are going to talk about data analytics. So data analytics is a very vast topic, so it's very difficult to talk about it within 3 hours or 2 hours period. So we'll try to we'll do something like this. You all know the story of watching the elephant for the first time. We have read it when you were a child, when a blind man was taken to an elephant and someone tried to explain him what was an elephant, right? So for some people, so some blind men, they put the hand on the leg and thought elephant was like a trunk or tree trunk. Someone put hand on the trunk of the elephant and they felt like it was like snake. So things like that. So it happens. So if I talk about a little bit of data analytics from here or there, you will feel like that, right? So instead of doing that, I will try to give you a picture of elephant today. So it's not possible to show you the elephant today. So I will try to draw a picture of the elephant for you today. That means we will try to cover the different aspects of data analytics today, but from a very top level point of view. Okay. Is that okay with everyone? Yes. Okay. Fine. Fantastic. So before we begin, let me just introduce myself. I am Sadiq Selim. I am working for SSMI USA, and I am their graduate master black belt. SSMI USA is one of the foremost Six Sigma and operational excellence companies in the world, organizations in the world. If I just go and give you some brief by it, it was created by Dr. Michael J. Harry. Have you heard of Six Sigma? Okay, fantastic. So basically, Dr. Michael J. Harry was one of the co-creators of the Six Sigma. It is said that he and Bill Smith they developed Six Sigma in Motorola. So this is SSMI is basically Dr. Michael J. Harry's company. We are operating in the Bangladesh for last 1 year or so, and trying to develop promote the goodness of Six Sigma in the country and also in the Asia region. Michael J. Harry, I think you all know. You don't know him yet that much. But he is basically a consultant to the Force 500 CEOs in different companies, in different organizations. And this is the very first Six Sigma Black Belt batch in the world. So that was conducted by Dr. Michael J. Harry back in 1985 or 86 in Motorola. And we are also, Jack Welch was a big supporter of Michael J. Harry all through. And so basically, we are here to promote the goodness of Six Sigma in around the world. So there are many companies who are doing Six Sigma and offering Six Sigma solutions to different parts. So what we feel that in that the main message or main concept of Six Sigma is being diluted as it is an open source platform and everyone is doing that. So we're trying to keep the original message and original concept as strong as possible throughout the journey. And we're also trying to promote it to different parts of the world. We have just started to promote it to different parts of the world, I think, couple of or 3 years ago. Before that, it was strictly, they are doing it strictly in the USA. But for the last 3 years, we are moving into other markets as well. And now at present, we have an office, head office, continental office in USA, UK, in Bangladesh, in Asia. The head office is in Sri Lanka. And in Asia, we are operating in Bangladesh, Vietnam, and Australia is also working on the Asian market. We are doing operational excellence consultancies, training and certifications, program management, and Our main focus is, as I always say, is mostly this promoted goodness of Six Sigma because to keep it alive as a data analytics tool or problem solving or decision making tool to the people. We say that we have saved around 500 billion for the different companies around the world for the last 16 years that we are operating in. And this is some of our global clientele. We have also partnerships with different universities in America, Korea, and Sri Lanka. Also, we're also doing a partnership in Bangladesh. Hopefully, which will come live in a couple of months. So we are working in Bangladesh also with the university to promote it. And these are our Asian clientele. We're mostly focused in Sri Lanka for the time being. We just moved to Bangladesh. We're doing from RPAC and some of the RMG industries as well. And we have different certification programs, starting from Master Black Belt to Black Belt, Green Belt, Euro Belt, and also TPM and 6S, those kinds of stuff. Now, why Six Sigma? Why is Lean Six Sigma? Why do we talk about this so much? Why do we try to promote it so much? Even if you go today, you will see that Lean Six Sigma is the most searched problem solving and decision making options or tools around the world today, even today. So this is others are doing it and are offering it. Now let's come to the data analytics. Okay, data analytics or primary understanding. What we try to do, as I have told today, we don't try to cover a particular topic. Rather, I will try to give you of the different kind of data analytics tools and techniques. Different types of data analytics tools, data analytics solutions are there. I will try to introduce you to different kind of software that you can use to data analysis and understand data. And also, we will try to focus on to see some of the softwares in action, right? So how we can solve the problems. And also, I will from time to time challenge your conventional thinking that if you have. So conventionally, we see data in a certain way. What is the most common way we see data? If I ask you to summarize data, so you're all accountants, right? Accountants and auditors. So if I ask you to summarize data, what is the first thing you will do? Yeah? Financial statements. And first analysis you will do? Variance analysis, right? That is the thing we are doing. We are preparing our income statements, balance sheets, working cash flow statements, and we are analyzing mostly to variance analysis, right? We are deducting one from the other and we're showing it as a percentage, right? Mostly we do it in column, we do it in row, but mostly that is the way you're analyzing data, right? Anyone is doing anything else? We're also looking at the ratios. Don't get me wrong, we're also looking at the ratios, but mostly we are focusing on the variance analysis and the ratio from a financial or accounting perspective of data. Today we will try to learn what other thing we can do to look in the data in a from a different angle, in a different way. So it may be a bit unconventional, you may find. You may also find this maybe a bit what I say difficult. I would say difficult, but I would say that this is maybe you can be more interesting or different from what you have seen or learned today. By the way, CC members have in one of their course we have studied about Six Sigma, right? There are some particular topics about Six Sigma and data analytics also. So basically, Six Sigma is a problem solving and decision making methodology. This is one of the biggest challenges in the world right now. We will see in a couple of slides why we are focusing on the problem solving and decision making methodology and why data is the most important part of it. Okay. Please, if you have any questions, you can ask, but not too many questions. We'll have a question answer session at the end of the session, right?
Yeah.
But if you have any immediate questions from pertaining to certain slides, you can ask. Okay. Also, the online you can also do the same. So now let's begin. So data analytics, what we'll cover today? Data and accountants. We'll try to understand the relationship between the data I'm talking about, not the data you are working on. The relationship between the data I'm talking about with accountants and auditors, whatever the works you're doing right now, right? So mostly I think accountants and auditors. Anything else you're doing? Anything else in the room, in the crowd? So I think that mostly covers it, right? The audience also. And what is data analytics? So we'll look into that. What is the different type of data analytics we have? And also the question answer session. So you're the job market, right? So have you seen the shift in the job market in recent years? how the job market is changing, not globally, but also in the local, in the Bangladesh markets. Have you seen? Can someone tell me the also the Asian markets as well? Can someone tell me the some of the examples? Share any example that changing shifts you have noticed in the market.
Everything is now online. We are now purchasing everything on online.
So there are more online jobs, online supporting jobs are being created, right? Okay. Next, anything else? So more digital jobs in the market right now. Okay. Anything else?
Everyone trying to keep their office paperless. So,
Paperless, right? So more cost efficiency and operational efficiency, excellence, those kind of jobs and needs have been is there in the market right now. Okay.
more automation software.
More automation, software development. So which means what? So you need more people who can work with computers and things like that, right?
Big data analysis.
Sorry?
Big data analysis.
Sorry.
Big data analysis.
Big data analysis, that's another area. We have now, the thing we have the most of now is data. Probably we have more oil than the data. Probably have more water. Probably have more data than the water we have in the world right now. In a nutshell. So probably someone sitting in USA, in Nevada or in San Francisco knows more about you than you. Right? What you are doing, what you are, what is happening in your life, what you are gonna do. Right? So what happened to you? They know it more than you, right? Why it happened? They know it more than you. Okay. What's gonna happen? They also know that it more than you. Right? So the job niches are shifting. It's not about traditional jobs anymore, right? So what happens is that the top 10 skills that will be required in the coming years. So let's see how it is changing. First thing is the complex problem solving. So problems are becoming more complex. Why? Because the easier problems can be solved through automation now very easily. Agree? So before HR function, you have this paper, you have to sign this leave application and everything. Your salary, you have to go and collect it from someone there, right? Everything, but now everything is automated. You don't even have to think about it. Because easier problems or less complex problems have already been solved through automation or software or something else. So now, what do we have? We have complex problems, more complex problems that organizations need to solve, that you cannot solve through merely by automation or things like that. Right? That is the one thing that is the high in demand even in 2020 going forward. Critical thinking. Critical thinking, it was like here. It was like in 2010, it was like here. 2014, it is now here. And now it is the second most important thing. Why? No one is asking about your knowledge. Let's see. Skills. Do you see the skills? No one is talking about the knowledge. Look at the skill list. Nothing about knowledge. Top 10 skill list. Absolutely nothing about knowledge. Maybe complex problem solving you have some knowledge element, but mostly nothing about knowledge, right? Negotiation is a soft skill. Creativity, you can encourage your creativity. We can work as a catalyst to your creativity, creative works, but we cannot teach you creativity, right? And then you have people management. These are mostly coordinating, emotional intelligence, judgment, decision making. These are mostly skills that help you to solve problems. If you look into those, what are those? Help you to solve problems. Creativity helps you to solve problems or create new things, right? You have people management to solve people problems. You have judgment decision making to solve those problems. We are talking about more customers more. So things are changing. Okay. Also, the job landscape if you see previously the top most declining ones are data. You don't need to data now. You put sensors and data being collected, right? Most of the time, you don't need to have someone to type the invoice and things like that. If you want, you can automate it. It depends on your wish. It depends on if you want it. If you want it, you can automate it. Accounting, bookkeeping, payroll, clerks, those kind of jobs are becoming declining. Administrative, executive, security, accountants and auditors jobs are declining. It's in the declining state. But what? Then what you are doing here? Okay, what SSC is doing here? If it is declining, what is happening in the market? Have you seen SSC's recent manuals and recent topics? They're actually shifting. There is less about accountancy, but there is more about other problem solving and other skills, right? Because things are changing. They also know this. Notice that. So either we have to adapt to the changes that are coming, or we have to do something else in coming days. Okay. So that is where the data thing comes in. Also, so the role of record keepers, the people who used to keep records, their role are becoming more like a data analyst these days. It's not more about keeping and entering data. It's more about telling the story behind the data. What story the data wants to tell, what story the data is trying to portray, right? We also have the reporters, the people who are preparing reports, IS, DS. These are all automated. You have no MIS now, right? Most of the companies have MIS now. So when you put the invoice data or the purchase data, things like that, you can have automated income statement, balance sheet, workflow. We take it and we tweak it a bit. We all know that what we do. But the majority, 95% work is done by the system, even today. Does someone disagree? No. Okay, so things are changing. And also there are softwares that will see the report, can see the report and tell you the findings. You don't need to analyze the report and tell them the findings. They will tell, they can analyze the reports and tell you the findings. And auditors roles are becoming different. Auditors role is not go there somewhere and finding problems anymore. Auditors roles has changed to not only giving recommendation anymore. It is about now what? Making decisions and telling that you need to do it. Auditors, they are going there, taking decisions, and you need to do it. Why? Because now they are working with data more, analyzing data more. Okay. So today we will try to see how we can analyze data, but in a fun way. Today is Ramadan, and I think most of us are fasting. So I don't want to make it a very boring session right now. So we'll try to have fun today. Okay, the way it's possible, we'll see. But I'm just trying to set the record straight that why this data analysis is very important for the accountants and auditors going forward. So what is in it for SSCI credential holders? In the whole organization, whatever organization you work in, who works with data? Who works with numbers? You guys. So who are the most fit to take on this challenge and upgrade their skills to this level in your organization? You guys are working with the numbers for your whole life, right? So who are better suited to take on this role of data analysis, data scientists, and those kind of things? All you need to do is upgrade some of your skills, right? Because you know numbers. You're working with numbers all your life. That's what you need to do. Second part is accountants are natural problem solvers. Why? When you show them a variance analysis, who does CEO ask why is there variance? Who does CEO ask? Does CEO call those marketing manager? Who does the CEO ask? You guys sitting there who is giving the report, they will ask you. So you know about the problems in the organization more than anyone else. So naturally you should be the problem solvers because you know the most variety of problems that comes with money. That thing that matters most to the organization. Right? You don't disagree? No. So that is the thing. So you guys are most suitable to take on these roles. You guys have the most big picture visibility. Why? Because you're working with all the expenses, all the revenues and all the things. You know in which branch the revenue is red. Right? And you know why it is red. Right? You know it all. So basically you can see the big picture, you can see the big picture, you can also go to the very ground level and see the small pictures as well. You look into the income statement in the top, and you also look into the different kind of invoices and things like that in the bottom, right? Changing business world. Now you need to adapt. You need to think about what's in Bangladesh. Probably it's not next 5 years, but maybe next 10 years. But you need to adapt. You need to prepare yourself for that. It's all about adapting your skills. I started my career in customer communication. I was a marketing guy. I started my career in communication. Now I'm talking about something that was developed by engineers. Right? So you need to adapt your career, you change your career to based on your previous skills. You don't sacrifice them, but you build on this, right? And is a cost optimization expert. The thing company loves most, management loves most is when you reduce costs. They love it more than when you give more revenue. Why? Can someone tell me also online? You can also post your answers there. Can someone tell me why? Why CEOs and management loves cost saving more than the revenue?
It will continue in the next month also. The same will be.
Yeah. Savings will continue. Revenue, you never know. Next month, next week, you may not have the revenue. But the cost you have saved, it will continue. And that is also the most difficult part to do in an organization. In Asian countries, the general practice is you lay off people. You reduce number of people, you lay off people, you shut down factories and things like that. Generally do that. That is the best way to see the cost efficiency. But also we are sacrificing on the potential revenue part when you're doing that. So there are other ways to achieve it, other ways to find it, how we can make it more cost optimized. Now, who can help them most about the cost? See, guys, marketing head, he cannot help, right? Sales head, he cannot help. He doesn't know much about cost. HR head, he doesn't know much about cost. He will say, I will cut 4 people, right? But you guys are the one who can know the cost, who can talk about the cost, and probably procurement guys can also talk about the cost to some extent regarding purchases and usage. And supply chain guys, they can also talk about the cost. So you are the two guys, two elements in organizations who can talk about the cost. So when I talk about data, when I see this, I don't see finance or accounting people using data analysis. Having said all this, generally I have been working with this data analysis for the past 12 years right now in different aspects and different companies or in different roles. But I don't see finance and accounting people are into it that much. So this is why we have talked to SSCA that how we can take them on board in this kind of initiatives, because they are the best people to do it. When I do a project for a certain company, I have to go to the finance people because they give me all the data, or accounting people, they give me all the data. Marketing people don't have the data. No one else has the data. So you have the data, you have the ownership. All you need to do is to have those analysis skill built in, and then you can deliver much better result to your organization. So it's not about cost control. In finance, you have a cost control function, but it is about optimization. It is about excellence, right? It's not control. It's not about control anymore. It's about excellence, right?
Sir,
Yeah.
data analysis is shifting from financial analysis to more behavior analysis.
Right.
Could you explain it?
The examples I gave in the beginning. Do you remember this? Example we're talking about, someone's, for example, about him, someone's sitting in San Francisco no more than himself. Why? Because he is giving his data, all his data in different social medias, in webs and things like that, right? He is giving it, all this. Someone is collecting the data and analyzing the data and knows what he wants. For example, if you go to the Google now, if you search Thailand package, what will happen for the next 7 days? What will happen? You will get all the package offers from Thailand, you will get air ticket offers from Thailand, you will get Thailand restaurant offers, and you will get different kind of offers that you will be able to discuss in Namata. But you will get all sorts of offers, right? All you need to do is go to the Google and search Thailand package, tour package. So what is happening? where data is being analyzed more now. Answer? And this is data analysis. What they're doing, they are analyzing the data in the backends and giving you options and solutions you need as per your behavior. Right? That is what is happening. So this is the way things will move on. For example, I'm a big Game of Thrones fan. You guys watch Game of Thrones?
Yes.
Yeah, one more episode left. Huh? Very difficult. So I get all the information about the Game of Thrones, different sources all the time in my Facebook profile, and I have to block those all day. Different functions I have to block because I miss other important information and things like that from my Facebook and LinkedIn. But LinkedIn has become a more of a now second Facebook rather than a professional site. So it is happening there, right? So the thing is, whatever you do in the digital world, someone is analyzing it and trying to get money from you using that. That is business. He's not analyzing your financial, right? He's not doing nothing. He's analyzing a particular part of your behavior and trying to get money from you. So that is the level data analysis is going through right now. And I'm just scratching the surface. It's more. It's much more than that. Okay. Sorry?
Sadiq bhai,
Yeah.
Hamza Said Ahmed have asked one question.
Sure.
He wants to know the cost optimization expert little bit more.
I have just answered it. Does it cover it?
He
Or
wanted to know a little bit.
Okay. Cost optimization is organizations, you have different kind of costs, right? So for the manufacturing organizations, the major cost in the manufacturing and supply chain management. We have mostly. So data analysis, proper data analysis and problem solving can have a very important role in reducing that cost. It's not about a one-time thing. Cost optimization in manufacturing or any other function, any other service, it's not a one-time thing. So what they can do, you can analyze the data and see what is the root cause. The keyword here is the root cause. We don't go for the root cause. I will discuss it a bit later. And we just solve symptoms. So when I have a fever, I just have a paracetamol. But I don't go and find why I'm having the fever. So when someone has done something wrong in the machine, what I'm doing, I'm firing people, the machine operator, right? Or I'm changing the machine. But probably that's not the root cause. So the root cause analysis part is missing in most of the companies I have seen in Bangladesh. What we do, we just go and sit in a meeting and try to find a solution. Isn't that the thing we do? Something happens, 4 or 5 people gather together, let's have a meeting, and no one has any data or anything else. They talk and they discuss from experience and then find a solution. Fantastic solution, it works. 1 month later, another problem happens. Right? So first you have fever, 1 month later you have headache. So first you have paracetamol, next you have Tylenol or something else. But no one is actually going for the root cause, trying to find the root cause. So when you find the root cause and when you solve it, you can actually optimize cost. For example, SSMI, you have saved around $500 billion for different organizations around the world in the last 16 years. And that's actually bottom line saving, not saving from the revenue. That's actually bottom line saving. So you can save optimization cost. Now, who is the most suited to optimize the cost in an organization? One is finance and accounting guys, because they know the data. They know where what is happening. And second part is the supply chain part, guys, because the majority of the cost is mostly there when it's a manufacturing environment. When the servicing environment, that's different. But manufacturing environment, most of the cost in the supply chain side, right? I hope that answers your question, Hamza. So what is data and data analytics? Let us think about talking about. I have a conference in Myanmar in some 1 or 2 months. So I was searching Myanmar hotels and I started reading this in emails, not even in ads in Facebook and other places, in emails. I just searched Google. So we have already talked about the point, what is happening here. So this is happening all around the world, right? Or every time it is happening. Hungry Naki, Food Panda, even in Bangladesh, some extent they are also doing it. some months ago, one of the local ride-sharing company, I won't name them, but you all know, was severely criticized for data leak, right? For data privacy breach and things like that, was severely criticized, things like that. But why they're keeping the data? Why they are loading up their valuable database space with your minuscule data? They were gonna use it, or they are gonna sell it to someone or someplace to use it for some financial benefit. Otherwise, why will they use up their valuable data storage space? It doesn't make any sense. Right? Keeping your data if it's not important. So data is what? First thing when you think about data, we talk about numbers. So it can be numbers, it can be words also, right? It can be sentence also, data. For example, when you analyze, we like yes and no. Survey. All of you have done survey. Some stage of your life. So there is a question. What is your gender? Male or female? We don't put numbers, right? We choose either male or female. But that is also data. So data can be numbers, data can be words, data can be sentence, data can be anything, data can be visuals. You have seen data science have gone a long way. You have seen the Facebook and other places, they recognize your face from photo. How do they do that? Right? Recognize your face from your photo. They will not detect. They will suggest you, recommend you. This is Sadiq Selim, or this is some Mizan, or something like that in the photo. How do you do that? They have created some algorithm behind that, some data analysis behind that, so that they can uniquely identify your photo from around, I don't know how many billion people are using Facebook right now. I don't know. Maybe 2 billion, 3 billion, 4 billion people are using Facebook. So out of 4 billion people's face, they can recognize you from a photo, picture, right? And this is how they're doing it. Data. They have analyzed your face such a way that they can identify your face out of 4 billion faces around the world. Okay. iPhone now have this face recognition, right? Opening the phone and everything, you have this face recognition features and things like that. And we often talk about data and information. The conventional wisdom is information is something that is valuable, right? So when we transform the data into something valuable, we call it information. This is the conventional definition we have been working in for a long time, but we never call it information analysis. Have you ever? We could never call someone information scientist. We often always talk about data analyst, data scientist, data analytics, but we never talk about information analyst, information analytics, information scientist. Why? Information is an output of data, right? But data, in fact, data itself has become so valuable right now. Even the data that probably doesn't make sense right now, it itself has become so important right now. The information is basically what we call the information and data basically same, because we never know which data will turn into a good information right now. No data is what I should say bad right now. This world, this digital world, is connected world. No data is good data. It is probably usable today. It is probably not usable today, or probably will use it tomorrow or sometime else. But no data is poor data. Okay? And also, data tells stories. Right? We use data to tell different kind of stories. In papers, we will say 345 were killed in road rage or car accident in the last month. So they put some data there, right? 345 number or something like that, and it is affecting it. So and it is telling you a story, and you are thinking of someone was walking down the road and someone was killed, some bus came and killed him, right? So data also tells stories in that way. And the most important part is data is telling us about our future. What is going to happen in the future? Predictive analytics, we call it predictive analytics. Predictive analytics has been going on for a long time. You guys have also used at least one predictive analytics tool in your SSCA course or in your lifetime. Can someone name it? Forecasting, yeah. Excellent. Another one?
Probability analysis.
Forecasting, sorry?
Probability analysis.
Probability analysis, yeah. Expected? Expected return. Warranty analysis. Anything else?
Regression and time series.
Regression and time series. Forecasting. We're talking about that. Regression and forecasting. So you guys have worked on that. So we'll also talk about that today, but in a different way. Not from financial perspective, but we'll talk about that from a different way. How it can help you to find out the root cause and find out the predictability. Okay. Next stage is prescriptive analysis. We will talk about that at the very end. Analytics.
There is one more question.
Sure.
Wakar Hassan has asked, what is the difference between data analysis and information analysis?
Data analysis and information. I haven't heard anyone saying information analysis so far. I've been working. This is a term probably non-existing right now. Basically, information is an output. Data is the something that we put in the input, we process it to analysis, and then we find the output as an information. So there isn't, I haven't heard of any information analyst or information scientist or information analysis so far. So this is a non-existing term, but this actually tells us that data is more important than information right now. Thank you. So data analytics data analysis is a method of interpreting data in a way so we can answer 4 questions. Your business is all about answering 4 questions. Right? Do you agree or not agree? From my point of view, from my angle, your business is all about answering 4 questions. Okay. What are the questions? What is happening in my business? First question is, what is happening? Next question is, why is it happening? So when you face a CEO, when you have a bad month or something, what is happening, right? Why is it happening? Go and find out. That's the next thing we hear. What you are guys doing? My sales is dropping, the product quality is bad, these things, people are returning products. What are you doing? Go and find out what is happening. Why is this happening? There's the first 2 questions. So what these 2 questions denote? It denote about the past. Whatever has already happened, right? What is happening means it has already happened. Or what has happened? Why it is happening? This already happened, right? And the next 2 question is, sorry, I think that what is likely to happen? If we don't change what is happening, what is likely to happen in the future? That is the impact assessment. If this continues, what is likely to happen in the future? And what do I need to do to solve it? So these 2 are futuristic. First 2 question is talking about the past. Next 2 question is talking about the future. Right? Business is all about answering these 4 questions correctly. The first one is what is happening means identifying the problem correctly. Right? Why it is happening means identifying the root cause behind the problem correctly. Okay? Then it is likely to happen. It can be one-time accident. For example, there is a road accident or your cargo vessel crashed or something happened, it sank or sunk in the sea. There's a one-time happening, right? So you cannot predict that when is the next cargo ship will crash or cargo vessel will sink, right? So that is, you cannot do that. But there are things you can predict. We can analyze and we can predict. That is also what is likely to happen. We need to do that because this is the impact assessment. Are the days after future good or bad? Okay. And if it is bad, if I see that whatever is happening today will continue in the next 6 months or 12 months, then I need to solve it. Right? This is the newest discipline. The next part is the newest discipline in the data analytics part. Okay. So 4 type of data analytics, the similar thing. You all do this. You all do this regularly. For example, CAN reports. What is CAN report? Regular report, right? Every week we have a sales report, right? Sales meeting and we discuss the reports. We have a procurement meeting and discuss the report, right? Whatever is happening and things like that. This is the CAN report. And ad hoc report, you also see that whenever something is bad happening or something is good happening, manager wants to see extra reports. We also look into that. Then we have the diagnostic part. Okay, these two are called descriptive analytics. What you are looking into, sorry? Question? Okay. So when you are looking into descriptive statistics, we are looking into our regular reports and ad hoc reports. Then we have diagnostic analytics. Diagnostic analytics, what we do, we try to find the root cause behind the problem. So we drill down. We use different techniques. Mostly what we do, we go and sit in a meeting and discuss. But there are other methods also. I think you have studied some of them. You have studied 5 whys, cause and effect diagram. You have studied FME and things like that. So there are other tools. These are qualitative tools that you can use, or you can also analyze the data. So here we have the data analytics part, diagnostic part. In predictive analytics, there are two parts. One is the statistical part, the things we have talked about, forecasting, right? We have talked about forecasting, regression, and those kind of things. Those are the statistical part. And this predictive modeling, this is the machine learning part. And here is another thing we also talk about a lot is machine learning, teaching machine to learn, so that machine can learn and deliver your predictions automatically. You don't need to interfere in the operation. Prescriptive learning, what is this? Prescriptive learning is giving prescriptions. So machine will analyze it, they will predict it, and they will prescribe you for you what you need to do. And in some instances, they will do the work for you, even do that for you. Okay, little bit of have been seen in Siri or Android virtual assistant. You can now tell them to Alexa, right? They tells you the time, they tell you to take the umbrella to go out right now. So if this is a chance of rain, they will tell you please take your umbrella when you go out because it may rain, right? So they're prescribing you, they're analyzing the data and they're prescribing you what you need to do before you know it, before you ask for it. So things are changing, right?
One more
Sorry.
question.
Yeah.
Does budgeting come under the category for predictive analysis?
Budgeting is a partially predictive analysis. It is predictive analysis. Mostly it is predictive analysis, budgeting. But it depends on lot of information you have, but it doesn't follow any particular model or method of a statistical predictive modeling or machine learning predictive modeling. It follows rather experience-based modeling mostly, and to some extent forecasting and things like that. Okay, so in that point of view, this is predictive modeling, but probably not a very good predictive modeling in the way we are doing it right now. For example, you have simulation techniques, right? Have you heard of Monte Carlo simulation and things like that? Some of you. So if you're using those, have you any of you heard of Oracle Crystal Ball? Used it? So Oracle Crystal Ball is a very good simulation software. You have assumptions, right? When you're preparing a budget, what the first thing you do? You prepare a list of assumptions. What will your inflation in the next year? What will be the dollar exchange rate of the next year, right? And many other assumptions, 7 out of 10 critical assumptions. And we keep those assumptions and prepare the budget. What we do? We set inflation at 10%, we set inflation at 8%, we set inflation at 6%, and we try to do some combination, try to develop 4 or 5 scenarios and best case and worst case scenarios. Now, Oracle Crystal Balls, there are software that will analyze millions of scenarios for you. So you just put the data there and they will analyze the millions of scenarios for you, and they will tell you, they will do the sensitivity analysis, the thing or something you very much, right? Sensitivity analysis. When preparing your business models or forecasting, one thing we do is sensitivity analysis. Have you heard of that? Right? That is the one thing we do to check. But those softwares do it for you. Okay, those softwares for you. They will do it and you can analyze. There so many information combinations. There are softwares that will analyze millions of scenarios in one thing. Okay, I will discuss this a bit later. Thank you. So Basically, what we're doing right now, listing analysis, I have also already discussed this. We're talking about income statement, balance statement, what we are doing about cash flow management, we're talking about MIS reports, we're talking about visualization. Right? We use graphs and charts to show management. Do we know which graphs and what is the right way of using graphs and charts? When to use which graph? For example, when to use pie chart, when to use bar chart, or when to use line chart. At the time, with the time in one axis, we're using line chart. So we see, we will also look into those. So I'll try to fix, I'll try to share with you we should use what kind of charts or graphs. So, I will tell you why we are using this. Doesn't it happen? Because there are certain ways of now. There are rules of using them. And then, in what happens, we mostly use variance analysis to find out, right? We don't do anyone, does anyone any hypothesis testing? Hypothesis testing? Anyone? That's the very strong tool to analyze problems or find problems. We will look into that. What is likely to happen? We use forecasting, we use scenario analysis, right? We use time scenario analysis. How to use regression? We don't use regression, right? Does anyone have used regression in their before? No. So, go back today. I will request you to find some data and do a regression. It is very powerful tool, much powerful than forecasting. In descriptive analysis, what do we do? We do mostly business reporting, right? We use dashboards. Management company will show different kind of dashboards, monthly dashboard, very beautiful picture which I could draw and show the management. We use data, visualize data, right? So the outcomes is summarizing business results or business outcomes. Whatever the management want to see, whatever we want to see. We leverage data for insights. Leverage data for insights means you have to look at the data from insights. For example, suddenly I see there is a jump in sales of what should I say, plastic material in Rajshahi. So I will think how I can use it, right? So does that mean that I can sell more in Rajshahi, right? Or does that mean that Rajshahi probably our product is very well appreciated there, or Rajshahi people are using it for some purpose that we don't know, that we can promote, but it gives you insights. It gives you incentive to analyze more when something changes, and interpret outcome from predictive analysis. You will all do predictive analysis. When we do variance analysis, what do we have? Target, actual, and then what do we have? Forecast, right? What is going to happen in the future? What is going to happen in the coming months? And management will ask you, will you achieve the target next month? You will say yes. And next month again, you will achieve the target. And again it happens, right? It goes on and on and on. So I think I have talked a lot, and the World Cup is near. How many days to World Cup?
Probably 1 month.
I think less than 1 month.
20 days.
20 days or something like that, 2 weeks. So I was trying to form an Asian team, a team comprising of only Asian batsmen. So there are 8 batsmen here, A, B, C, D, F, G, H. They are actual batsmen. I have hidden their picture. I have not given their names. So I went back and analyzed the data. Okay, the performance data of the last 8 or 10 innings. How much run they score, what is their average, and things like that. Now for this analysis, for this game, let's think that their strike rate is same. Okay, per 100 ball strike rate is same. Let's assume that. Okay, so we have to fix some variables. We cannot work with all variables. So let us fix some variable that strike rate is same. And now my question is, which batsman will keep in your team? Can you decide? Okay, we will take 5 batsmen and you will leave 3. So which 3 batsmen you won't select? You all know cricket. I think in the online also, I think they're from cricket playing countries. Pakistan, Sri Lanka, and UAE or things like that. They're from cricket playing countries. No? They know cricket. Yeah. And these are Asian teams. There are 2 Indian players, 2 Pakistani players, 2 Sri Lankan players, and 2 Bangladeshi players. But I have hidden their pictures. I haven't hidden their name. You have to select which 5 players you should select in your team.
I won't select ACN.
You won't select
ACN.
A. A has the highest average.
What is the age? Oh, it's
Average. Average.
Sorry, I'm saying age.
Oh, that's the average. So these are the players, and this is their average, right?
Then exactly the opposite.
So which 3 players you won't select? So who will not select A? No one. Everyone will select A. Who will not select B? There are. Just put your hands up. Huh? 1, 2, 3, 4, 5. I think there are around 30% people who won't select B. Who will not select C? Who will not select C? Everyone will select C.
Based on this data or we can consider other data?
If you have other data, you can consider. You can ask from me for other data.
The average rate might be high, but the performance is not that much.
What do you mean by performance?
I mean, form is not right now.
No, I think this is the recent score. This is the last 8 innings or 10 innings score. Recent score. Expected is same for all. Expected is same for all. Fair enough?
Yes.
Okay. D. Who will not select D? Who will not select D, right? You guys don't select D. So B and D, we have people who don't want to select. E. Who will not select E? Everyone will select E. Who will not select F? 33 average, huh? Bad player. Very bad player. G. Who will not select G? Everyone will select G. So we are not selecting B, D, and F, right? B, D, and F, right? Bangladesh, Dhaka, and France. Not selecting, right? Okay. Now I give you some more data. There is standard deviation score. Do you understand the standard deviation?
Yeah.
No one talked about it. No one considered it before selecting players. Now select again. Anyone want to change?
Yeah.
Huh? So, who you will not select? Okay, let me ask you again. A, how many will not select A? Everyone will select A. Computer segregation. You will not select 1%, 2% will not select it, 3%. Why you will not select it? Segregation is very high, right? B. How B is okay when A is not okay? Whose standard deviation is high, A's or B's? No, think again. Whose standard deviation is high, A or B? Why B? Why A? Why B? Tell me. Whose standard deviation is high? You understand the division variation, right? So whose variation is high? Whose variation is high? Whose percentage of variation is high? B average is 34. Isn't it 34? 100% variation, right? 100% variation, right? Possibility of scoring 0, right? So now A or B, who will you select? You guys are changing pairs. You know, one time A, one time B. Fix. Don't do that. Okay? So let me give you some more data. This is the summary. Okay? What I have summarized? I have summarized from this that if they perform one standard deviation away from the mean, what is the potential score? So this is the average minus 42, 57 minus 42 is 15, 57 plus 42 is 99. Yeah, everything is calculated in that way. Okay, so this is 68% probability. Statistically, there is 68% probability that their score will be between 15 and 99. Now, who will you pick and who you won't pick? Anyone will change again? Again, going back to A. Okay. B? We don't like B. C? Now think about strategy. This is a ODI match, right? World Cup is an ODI. It's not T20, it's not test. So think which batsmen will be more successful or which batsman you will need more in your ODI. Okay? Which 3 batsmen you can sacrifice? Think. Okay? A, everyone is taking? Okay, B? B, no one likes B. C? C, no? Why? C, average is 30 and standard deviation is 47. Okay, let me help you again. You have, we will choose 5 batsmen, right? So what is your strategy for choosing the 5 batsmen? Fix the strategy at first. Before jumping into conclusion, looking the data, this is a one-day game, right? Sorry. This is a one-day game? So what is your strategy? What do you need? You need some players who will be consistent. You will need some players who will be dynamic, and you will need some players who can score big. So at first think about the combination of the 5 players, right? So this is how you analyze data. You use data to take decisions. So what is your combination now? Your combination and your combination may differ. That's okay. The coaches are different, managers are different, but you need to at first understand your strategy, right? So, for example, if I am making a team, I will want 2 consistent players who will give me some score consistently. I will select 2 high scoring players, and I will select a, in our language we call lottery player, right? Yeah? I will select a lottery player. If he hits, the game is done. But there's a chance I'm willing to take. But that's my strategy. Your strategy may be different. You may choose to have 5 consistent players. So find the 5 most consistent players from it and choose. Right? So now at first we thought something. Now then with some more data we changed our decision. And now with some more data we are again changing our decision. What was lacking? First thing is big picture. You're not thinking properly. You're not asking the right question. He told me that someone there was asking about strike rate or other things, right? What are the other things? There are other things, but you need to understand what is the other things you need to look into. Average means nothing. In a statistical world, average means nothing. Without a standard deviation or without variance. Average is nothing. Average absolutely means nothing. Right? For example, someone can score 5 50s in a row and score have an average of 50, or 4 50s in a row and average of 50, and someone can score 0 100 0 100 and can have the same average. Right? But they are not the same players. They're not same type of players. So you will have to choose which player you will select in which condition, which situation. But to do that, you have to have your strategy. How you are trying to use this insight or the data for your team building. How do you see your team? Do you want to be like England and everyone is comes and hits, right? Or do you want to be like some other team? I don't know, maybe like Pakistan, where they selectively some people hit and others don't hit, right? Or do you want to have like players like Andre Russell and things in the 4, 5, 6 who will come and hit and take the game away? This depends on your team, your decision, how you are thinking that the World Cup may be won. That is your strategy, but you have to select players based on your strategy. But this is the information you can use to do that. Okay? Was that fun? So let's look at the players. These are the players. Okay? So, which players did you select? Tell me. Which players? Did you select any Bangladeshi player or no? Not good. Out. Or in Pakistani player out. Indian player out. Sri Lanka player out. Huh? When you analyze objectively, you see analysis changes. Now, if I want to ask you to select players, you will select differently, right? There is the difference between analyzing using data, analyzing using perception, analyzing in meetings. There's the difference. Okay. So when you using the data, you are having some kind of perception selecting players. Now, as I saw you these players, this Bangladeshi crowd will select those 2 players at the beginning, no matter what. Okay, they are in the team. Pakistani crowd, those 2 players, right? It's like that. Sri Lankan crowds, those 2 players in the corner. This is the perception we have, right? But when you select, this also happens in the business as well, right? So when you analyze in meetings and analyze not using data, we tend to make mistakes based on our past experience or our preferences or our situation, right? So when you are analyzing data objectively, it changes things. So descriptive analytics is very, very, what should I say, non-reliable unless done in the right way. So when you look into the average, it's extremely non-reliable, right? So later we try to put some more informations. We go on the standard deviations. I could have put more information. What was the score in the last 3 matches, right? Things like that. That would have been helpful you to take the better decision more. But when I put into the picture, everything changes. Whatever you selected earlier, you forgot. Now we will select based on which players you like or not. Agreed? Okay. So we are talking about data visualization, right? One major part of descriptive is data visualization. What time is it?
480.
Okay, I think we need to speed up a bit. So data visualization, we try to look into the data and bars and try to understand when should we use what kind of graphs or charts to analyze what kind of data. I've already written here, but you can see when should you use column chart and when should you use bar chart. Column chart versus bar chart, same. One is this way, one is this way, same. That's the orientation. But when should we use which one? When should you use bar chart and when should you use column chart? Sorry? You can, but that's not the point. You can also do here also. You can put the years 2016, 17, 18, 19 column chart also. What is the major difference? Exactly, column charts, we can use more categories. Why? Because these text in bar charts, if I put 10 categories, these text will break up. Simple. These text will break up. You won't be able to show it in bar chart. Right? So better is column chart. When you have more than 9 or 10 categories or 8 categories, use column chart. Don't use bar chart. Haven't you seen? Dhaka is okay. But when you go to at Maimon Singh goes up and Singh goes down. right? When you do it like this way, doesn't it happen by region? When you put 9 division of the things like that or countries like that, it will happen. But it is not supposed to be like that. Charts are supposed to be visually appealing. That's why there are charts and graphs are using. So if in a chart the word breaks or it is not appealing or it's not good enough, then there's no point of using that chart, right? Okay. Next is structure, right? When do you use structure? And there's two kinds of structure. Can you tell me the difference? Right. Here, what we did, we have only the number, absolute value. Here, we have absolute value, but we convert it into the percentage, 100%. For example, 100% of quarter 4, who is contributing what? Similar chart, but depicting different pictures. Right? Can you see that? So things will change with data. Pareto chart. Have you ever seen this Pareto chart?
Yeah.
Right. What does Pareto chart do? 80-20 rule. What is the 80-20 rule?
80% causes, 20% causes will solve you 80% result.
Basically, 20% causes generate 80% of the problems. So if you solve those causes, your 80% of the problems are solved. Right? This is called the 80-20 rule. 80-20 rules goes into different many things in life. So for example, for a company, just look into this. We will use this in analysis in the coming slides. So look into this. What we have done here? So what I ask the sales people that your sales are going down, right? Your sales are not going up, your sales are going down. You are doing well. So what's wrong? They tell me there are so many defective products. Sorry.
Please repeat the 80-20 rule.
Oh, 80-20 rule is basically in this scenario, 80-20 rule is 80% of the problem are caused by 20% of the causes. Okay. So whatever the number of problems are, 80% of the problems are caused by 20% of the causes. So if you solve those 20% or eliminate those 20% of the causes, you can eliminate 80% of the problems. So 80% of the problems caused by 20% of the causes. So there are defective products. So what is the order here? The bar chart. This is a bar chart, right? Or histogram. Histogram. What's the difference between histogram and bar chart? The difference is there's no gaps in between, and in histogram we put the count in a order sequence, and here we are putting it in ascending order intentionally. Okay. So what is happening? I see the most of the. So what did my salespeople say? My salespeople said, sir, most of the problems are for defective products. Our products are defective. Customers are returning it, and I've been having to give them refund for that. That is the major problem. Okay. Then I ask them what is the other problems. They tell me the wrong product delivery is a major problem. We are delivering wrong product to wrong people. We have unavailability of product. Okay. When I ask for fan, they give me light. The customer wants fan, but we don't have fan. We have lights. Right? It happens in business. When your product mix is not right, it happens. You don't have the product that customer needs, and you have more of the product that a customer don't have. Right? We have that. And no product information. There's another problem. Customer is not ordering more. Delay in order processing. We take so much time in order processing. So what do we do? 80-20 rule, right? So we look into here. 75% here, 84% here. So let's suppose we can take 76%, 75%, right? So what we can say that these 5 problems are causing 76% of the problems, right? These 5 problems are causing 76% of the problems according to our salespeople. Salespeople complain, they are telling me that these 5 problems are causing 76% of the problems. So let's go and solve these 5 problems. Right? So now we know that our sales drop, but now we have some idea from not quantitative data, but our people say and customer complain that these 5 problems may be the starting point where we should look into. We have fever, So now we know that what might cause it. Maybe I have tested, did a diagnostic test, and my ESR is high. ESR, when you have infection, your ESR goes up. So now you know that your fever may be because of this infection, and infection may be one of these 5 causes. But I still don't know which infection, right? But this can be one of the 5 infections that is causing it. Others are okay. Just remember this slide, we are going to use it. Some information from this in some analysis in the coming slides. Waterfall chart, I think you guys love it, right? This is the newest trend that began in the last 5 or 6 years, like waterfall chart. Everything is that we can show it. What do we show in waterfall chart? Incremental changes and
I mean, one start point to end point.
Yeah.
Exactly, incremental changes to how we reach there.
3 things we use. We use waterfalls chart in mostly for 3 things. One is when we are showing income statement and it's positive, right? When it's negative, we don't use waterfall charts. But when it's positive, we use waterfall charts, right? That's positive, we are doing good, let's use it. So the management, yeah, we have this and this. Second, when do we use it? Cash flow statement, right? We show the cash what is going and coming up, and end of the day what the cash is there, we show it. Third place we use it in projects, right? So in projects and operations, the cost is going, some revenues and things like that. So we break it down and we show the remaining amounts what we have. Then we again say what is the other cost and we try to use it. So waterfall chart, generally in businesses, we use in 3 things. One is when you show income statement and when you have positive data. Not if you have negative red and show a waterfall statement, you may be problem. Okay. You don't have any work, you spend your time in doing a waterfall chart when your business is red. Okay. And then you use it in cash flow statements, and you also use it in project situations, right? Okay. You guys love it, no? Waterfall chart. Okay. Pie chart and donut chart basically same. There's no difference. It's just 2 way of showing data. Okay. Which kind of data we show here? Percentage data. Definitely. We shouldn't use it for showing any other kind of data. This is our percentage data. Line chart. So far, I haven't talked about time. See, I haven't put any month here. I have talked about quarter a bit, but not about more data. So now we are talking about time, January to December, and then we do simple line charts, right? Trend chart, and we can do forecasting on this. We can find out seasonality here. If there's a seasonality elements, if you have more data out there, if there's a trend here, if there's an oscillation here, okay, there's other things. There are 8 things you need to see when you're drawing line charts. Okay, there are 8 things. And we're not going to cover it, but you guys can go back and check out run chart. Line chart is kind of a run chart. So you go and check out run chart, and you can see what are the 8 things I'm talking about. So line chart, we basically look into 8 things. Okay. But what happens when we do this? Right? We love line chart so much that we start using line chart and then no one understands anything. Okay? There's too many lines, too many things that we cannot see and we cannot easily understand. So what do? We do area chart. Area chart is giving us a better picture than line chart. It tells us a better story. Okay? So now we know when to use what kind of charts better, I think, from previously. Why are using some kind of charts, why there is an area chart, why there is a pie chart and other things. Because everything is a reason. Right? So then, rather than showing those 5 clumsy lines, we can use area chart to show the same information but in a different way. Okay? Scatter plot. Have you used a scatter plot before? Anyone? Anyone? Loving me? What is scatter plot? Regression. Yeah? Regression is nothing but a scatter plot, right? Right. For example, what did I do? Remember the table? I talked about Pareto table. So they are telling me that sales order is number of sales order is decreasing because they are defective products, right? So what I said, no, I'm gonna go back and check. So I put the months here. In what months, what is the sales order did we get, and what is the defects? What are the number of defects we have? And I wanted to see if my that has any relationship with my decreasing orders, number of orders in coming months. But what do you think is happening here? Is there a relationship? There's no relationship. If there was a relationship, then what would the line look like? It would be like this, right? Or this. It can be inverse. It can be this way. But now the line is looks like the line is like this, na?
We cannot draw the line.
We can. We can always draw a regression line. The accuracy of the regression line may be very low. The R square may be very low, but we can always draw a regression line.
It depends on the correlation.
Right. So there is no correlation. What you're watching here. So I know that my sales order is not dropping due to defective order or defective things. But I haven't seen the data yet. From the visualization, I can understand that, interpret that. Maybe I can analyze it through a regression. I can do a regression and see if I am right or wrong. Okay, we will do a regression later. We will look into regression later. Okay. Spider chart. Going to spider chart. When you are comparing two things, for example, target or actual, last year or this year. Okay. So here different parameters. We're comparing to not more than two, then it will be clumsy again. So if you're comparing last year and this year, target versus actual versus forecast, you can use spider chart. So it will show you how is the biggest gap or biggest things easily, right? You have to look into others, but don't do it for more than two variables. If it is 2017, 18, 19, don't do scatter chart because then it will be so clumsy. It will become clumsy. But if it is only 2018 and 19, the scatter chart, sorry, spider chart or radar chart. Okay. So we have covered more of data visualization techniques and things. I am just going to talk about a tool a little that I personally love to use. Okay, this is called Power BI. Have you any of you used Power BI? Power BI? Used it? Little bit. How do you find it? Sorry?
In my organization, they actually introduced influence.
Yeah. How do you find it? Using it? Have you used it?
I'm just using this video wire.
Okay. Power BI is basically data visualization tool by Microsoft, right? So a Power BI dashboard can look like this, and it can look much better. It depends on your imagination how your dashboard can look like, and you can have dashboard in real time, and also you can change the dashboard and monitor data and everything. So you can just put the Power BI in the server. The dashboard is server, and the data can, when the data is entered, the server data can change and everything, and management can see a very real-time pictures of data and information you have, right? Data visualization. But select the charts based on the principles we talked about previously, right? So Power BI, I'm just trying to give you some idea or some tools, also same process which can help you in data visualization analytics, and I will continue to do so throughout the presentation. Okay. And Power BI is free. It is free, and server is also free. But for advanced features, you will obviously have to pay. But mostly it is free. Okay. So we have talked about descriptive analytics, right? We have talked about data visualization and understanding data. So now we are talking about diagnostic analysis. What is diagnostic analysis? So far we have talked about here what has happened, right? Now we are gonna. This is in the past. This has already happened. These are all past information. Now we are going to talk about, try to find out why it is happening. Okay?
There was one question. What is
Sure.
CAN reports under the heading of descriptive
CAN
analysis?
report is basically what we call is regular monthly reports that we always have. Mostly, sometimes we see this report, sometimes we just archive it without seeing. And people send these reports sometimes by email. This is a term, buzzword term. Methods for root cause analysis. So what we're talking about diagnostic analysis, we're mainly talking about root cause analysis. We had fever, right? And we have high ESR. ESR is an indication of that I have an infection. Now I have to find where is the infection, why is the infection. I can have antibiotic and solve the infection, but it may not solve the problem. The infection may reoccur, right? Recur again. So I have to find out why this infection is happening. Right? So I need to do more tests to find out. So that is the root cause analysis. Why this infection is chronic? Why this is happening every time I am doing something? So let's do that. So previously we did what happened? Discovery analysis. So we identified the problem. Our for summary sake, our salespeople told us there may be 5 possible problems. Some will delivery, some will delay. The 5 possible problems. Okay. Diagnostic analysis, you use this kind of tools. We use Six Sigma, we use Lean tools, we use 8D tools. Difference between Six Sigma and Lean is both are problem solving and decision making tools. Let's get it clear. Okay, it's not that both are working on different things. Some say that Six Sigma works on variation. We talked about variation, standard deviation. So the first way Virat Kohli, his average was 57, but his standard deviation was 45 or something, right? So if I can reduce his standard deviation, for example, it is not 47, it's 45, it is 5, and if I can increase their score from 57 to 62, then in every match he is gonna give us 60 to 70 runs. Very good, excellent, right? So some say Six Sigma talks about this reducing the variation. If you are reducing the variation, you are saving money. Okay, and Lean talks about eliminating waste. Some say, I am telling you some say, then I will tell you what is the actual thing is. Lean talks about eliminating the waste. Lean is based on 5 principles, but the 3 main words of Lean is Muda, Mura, and Muri. These are Japanese words. They were developed in Japan. So Muda means unevenness. So Muda means waste. Mura means unevenness, variation, and Muri means stress. So what they're talking about is waste are causing variation, and which are causing stress in your operation and things. So if you can eliminate waste, your variation goes down, and your operation stress goes down, and your operation performs well. You save your cost. Okay. So both are in a way trying to save a cost. Now this is very generalized explanation of Lean and Six Sigma. Okay. Basically, Lean also works in Six Sigma also works in reducing waste, reducing variation, and everything that Lean does. But Lean has a particular set of tools, and Six Sigma has a particular set of tools and techniques. Right? They are trying to do the same things, but using different set of tools and techniques. In accounting also you have different principles, right? You have one is GAAP, one is other accounting bodies also with different kind of systems of record keeping and everything. It's same things like that. Both are trying to do the same thing, solving problems and helping you making decisions, but using different kind of tools, different set of tools.
Continuous improvement related
Yeah.
with some
Yeah, continuous improvement is a concept. Continuous improvement concept is improvement never ends. Okay. So even if you have 0 defect today, for example, you go into the operation, okay, you eliminate all waste, there is no defect there, you can produce many items, right, and you full capacity, nothing there. What can happen tomorrow? Can someone tell me? A new technology may come, and you can become obsolete. Same thing happens to cameras and other technologies all the way around. So you can have the best of an operation and everything, and then all of a sudden you don't know. So continuous improvement concept talks about you always have to strive for excellences, and you also always have to strive to have best practices in your organization, and always should be updated with the organization and people, things like that. We Asian countries, Bangladesh, Pakistan, Sri Lanka, I would say mostly, we were very safe previously because we were not impacted by globalization law. But for the last 10 or 15 years, we are getting the impact of globalization, right? So whatever happens in America, also have some impact in Bangladesh right now, right? When the Telenor share, when something happens in Grameenphone, the Telenor share price in Norway goes up and down. It's not, we are not isolated anymore. We are connected. We are part of the global economy very strongly right now. That is good and that's also bad. So when global economy is bad, it will suffer. It will, we will be sufferers. When global economy is good, we will be better. That also goes for technologies and operation and things like that. Okay, it's not only about economy. For example, we may not do it, but Vietnam can do it. Right? They can update and they can use automated machines and things like that. And we may be delayed and we may not use it. Right? So things are impacting us in this way. These things will impact. So we have to continuously improve. We cannot stop to improve. Okay.
Can you briefly intro about 8D?
8G we are not going to cover today. 8 is basically there are 8 principles, 3, 5, and 3, 3, and 2. We are not going to cover today. Okay. I will try to share some article on that with SSCA. They can share with you later. Okay, if that is okay. Okay. So in root cause analysis, generally we use these things. 7 quality tools. I think you have heard of this. Some of you. This is the basic tools you use to analyze root cause when you are using Six Sigma principle. Okay. And then you have hypothesis testing. I have talked about it. I will show you how it is done in a bit. So what are the 7 quality tools? The first one is the cause and effect diagram. What is cause and effect diagram? No. Fishbone diagram. Anyone heard about it? Ishikawa diagram. Ishikawa diagram, fishbone diagram, cause and effect diagram are the same thing. Same thing, okay? So what happens? We put effect in one place. For example, our effect is decreased sales order, right? And we draw like a fish scale. And each of the scale, we try to put the causes, okay? So I think it doesn't come out good, right? This is a scale, and each of the scale, we try to put into the causes related to this. So this is cause and effect diagram. Okay. Then we have flowcharts. Flowchart is something we use all the time. But when you explain something to your friend or colleague, you take a paper and try to draw things, right? This is flowchart, basic flowchart. We always do that, right? We also put numbers. This is also flowchart. So flowchart is mostly used in operation or manufacturing, also service, to explain how product and services are transforming to something else, right? Or changing hands and things like that. So when you do flowchart, you can see the gaps. How? For example, you can see that something is waiting in the warehouse for 3 days. Why? So when you draw the flowchart, it helps you to ask the right questions. Okay. So when you draw the flowchart, what happens? You can see some discrepancies that doesn't go into common sense. For example, why they are keeping those material for 3 days in the warehouse while they can deliver it today. And then if you go back, you will see that there is some control mechanism or something. And then if you eliminate this, then we don't need it. You can just deliver it. So flowchart helps in that way. Checklist is another way to ensure that what is happening. So for example, if we had a fixed time for everything, for example, fixed time for production, fixed time for delivery, fixed time for checking, quality checking, and in the checklist, check sheet, we used to keep those records, and from that we can know how we are doing bad or good, or why we are not performing well, right? Also comes Pareto. We have already talked about Pareto. Histogram is basically a frequency chart where we look into the data from a frequency point of view. Control chart is another mechanism. We are not going to cover those today because we are going just trying to introduce you to this kind of tools. And scatter diagram we have already covered, right? We have seen. So we have seen scatter diagram, Pareto chart. You understand check sheet a bit, but these 4 maybe we need to go back and look into this more. Okay. Then comes the difficult part. Huh? So this is basically more qualitative. This is quantitative. Now we are going to analyze what is the result, why it is happening. Sorry, this is the result. Why it is happening? Okay. But this is a very clumsy chart or very big chart. Okay. So the hypothesis testing is what? Have you ever done hypothesis testing? Hypothesis testing is, suppose I tell here that 30% of the male or boys in this room are wearing shoes. Okay, or all in this building are wearing shoes. So how do you check that? Will you go to everyone and check them if they are wearing shoes or not? No, you will take a sample, right? So you will take a sample, and from the sample you will see if 30% of them are wearing shoes or not. So if they are wearing shoes, we will say yes, the hypothesis is true. If they are not wearing shoes, we will say no, the hypothesis is false. It's a simple principle, but it has some twist in it. I'm going to come to that in a minute. But it's a simple principle. So hypothesis testing is whatever we want to prove. For example, in our business case, in our sales order case, reducing sales order case, first thing we wanted to prove is that it is due to delivery delay. No, sorry, it is due to defective order. But you said no. So the hypothesis was key. The hypothesis was the delay is due to delivery order. But we proved that no, it is not due to delivery order because the scatter plot didn't show that, right? Scatter plot we did sometime ago didn't show that. They said there's no relationship with service order with defective order, right? So there's no relationship. So we can say that hypothesis is not true. Okay, we hypothesized that delivery order, we'll just focus for a minute. Hypothesize that number of decreasing order is related to higher delivery order, higher defective, right? We hypothesize that as there was more defective items, we are getting less delivery orders. Hypothesize that, but when we look into the scatter plot, we saw that it's not true, right? In some charts ago, we look into the scatter plot here. What is this? What is this? What is this? Huh? Here we see it's not here. The line should be this, but line is not this. So we can conclude that the hypothesis was false. Okay. So in hypothesis testing, we make a statement and we try to prove that statement. The statement is generally relationship between two or more variables. Okay. Suppose now let's do a hypothesis. There are 19 hypothesis testing we do. 19 types of hypothesis testing we do. Generally, I will try to show you one or two of that. Okay. Before doing hypothesis testing, we need to know what is data. What is data type? What is attribute data? Can someone tell me? Attribute data and numerical data. You know discrete data, continuous data. What is discrete data? What is continuous data? What is attribute data? What is numerical data? Discrete data is discrete. Continuous data is continuous. Yes. What is continuous data? Continuous data is something. He's right. He's not wrong. He's right. Continuous data is something that is going on, moving on. There is no gap in between. For example, there is no fraction. For example, his age right now is 25 days, 25 not days, 25 years, 3 months, 4 days, 7 hours. 30 minutes, 2 seconds. 30 minutes, 3 seconds. And it's continuous, it's going on, right? It's not stopping somewhere. He's right, it's not wrong. It's continuous. Time is continuous. There are many things that is continuous. Possibility of being continuous. Weight is continuous. You are not 90 kg today and 100 kg tomorrow. You are measuring it after 1 week or 1 month or 1 year, but it is increasing continuously, right? It's not about you are 100 kg today and 110 kg tomorrow and 10 kg increased. What? It's not like that, right? You're putting on it continuously. So he's right, it's continuous data. And what is discrete data? Discrete data is color. Let me give you an example. Color. Red, blue, green, yellow. Can you put a number on it? Can you put it in continuous motion. Red comes first, then green, then blue, then yellow. Can you do that? No. Yes or no? I ask you a question. Gender, male or female? Right? Discrete or continuous? Discrete data. Right? It is not 80% male, 20% female, then 80%, 81% male, 19% female. It's not like that. Male or female. Right? It's like that. Then others? Now there is confusion. I have told you the easiest two. Now I will not tell you the difficult one. That is the ordinal. What is ordinal? Class 1, class 2, class 3, class 4, class 5. It is discrete or continuous. This is discrete. In a statistical term, use it as discrete. Right? You are in class 1 in class 1, but you are not in class 1 4 months, 7 days. Right? You are in class 1 or you are in class 1. Right? You are class 2 in class 2. Okay. You are a GM, you are a GM. You are a DGM, you are a DGM. You are a manager, you are a manager. But you are not between manager and DGM. There's nothing in between. There are order. I want to say there is an order, but the order is not as defined as continuous one. So you are not like I am manager 2 weeks, 4 months, something like that, and then I am 2 DGM in 7 days, 9 months. It's not something like that, right? You are either manager or a DGM. You are not nothing something in between. Something in between. So this is ordinal data. So we have binary. Binary is yes, no, male, female, 2 factors, right? Numeral is colors or things like that, right? Ordinal is there is an order. Class 1, class 2, class 3, class 4, class 5, GM, manager, GM, DGM, manager, senior executive, officer, blah, 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 and things like that. And this is the ordinal. And count. And the thing is, we haven't talked about is count. So count is generally, we call it discrete data. But here we are talking about numerical and attribute. So count is a numerical data, but it is a discrete data. Count cannot be in between, right? There are 7 people and 8 people. There cannot be 7.3 people in this room. Is that clear? There can be 7 people or 8 people, but there cannot be 7.3 person in this room. So count is discrete but numerical, right? So for this hypothesis testing analysis, we divide it by attribute and numerical. We consider count and continuous data as numerical, others as discrete. Okay. So you remember the Pareto chart I talked about? So what I did, they were talking about customers who are given wrong product delivery is less likely to give a repeat order. So what did he say? Customers who are given wrong product delivery will not, it's less likely to give orders. So what I did, I went back and I collected data. So I see the wrong product delivery were given to 100 customers, right? And 70 of them gave repeat order. That is 70%. And I went to, then again saw the right, what happened to the right product delivery. So right product was delivered to 980 people, and out of those 800 people gave us repeat orders. That is 82%. So this is 78%, this is 82%. There is a 4% gap. So what is your conclusion? Tell me. Smart boy. I'm giving you more data, but others, I want to listen to others. But what is your conclusion from here? Wrong product delivery, repeat order rate 78%. Right product delivery, repeat order rate 82%. 4% difference. So what do you conclude? Less likely to order. And others? He says he needs more data. Anyone else? There's no more data available. That is this. No more data. Others? Okay?
There is some other problem.
There is some other problem because
Hypothesis is wrong.
Let's test hypothesis. We haven't tested this. We have just seen in our most favorite way, that is the percentage, right? But let's look at what hypothesis testing said. The right way of doing this hypothesis is test for two proportion. Okay, so there is a why, because this count data and things like that. We are looking at the percentage. So basically, we will do a test for two proportion, and we look into the p-value. P-value is, he was talking about probability. Someone from here, p-value is the probability value. So the probability of this is 0.05 and less than 5%. Okay, probability of this happening is 0.05, which means what? It's greater than 0.05. So this is something we call chance. So what we call is that there is a at least 5% chance of something happening by chance. 5% probability of something happening by chance. Okay, and if it is more, then we can say that there is no difference. If it is less, then we can say there is a difference. Okay, here the p-value is 0.40. The p-value here is 0.40 means that there is no significant proof that there is a difference between wrong product delivery and right product delivery percentage. Yeah, there is no significant proof that there is a difference between wrong product delivery and right product delivery percentage.
How you derive this?
This is the hypothesis testing. This is a statistical analysis. Okay, I have the software. We call it Minitab. I put the data there and we can prove.
Yeah, I was thinking manually.
Yeah, not manually.
Yeah.
So this is a manual calculation. I can show you how it is done manually. But generally, we have a software and things like that for that purpose. We put it there. You can also do it in Excel, test it in Excel also. So you put it there and they tell me that no, there is no significant difference between wrong product delivery and right product delivery. So what do we see? We have 4% difference when we check here, right? But when we did the hypothesis testing, they tell me there is no significant difference. There is no significant proof that they are different. Now we are thinking a different way, right? So I'm just trying to encourage the different thinking in your process, in your thought process. The percentage, we often look at the percentage and take decision. Maybe the decision is not right. Maybe, just maybe. In case that maybe the decision may be wrong. There's a possibility, there's a probability, high probability, the decision may be wrong if we just take decision based on percentage figures and variance analysis. Okay? So this is data analytics we talked about. So what is happening here? What did I do? So I went back and checked for everyone. There are many factors are there, wrong delivery and everything, many things. So I checked for everyone. I didn't find very correlation between them. The data was dummy data. I just created dummy data from Excel from range using range between and range functions. The data was dummy data. Obviously, there can be those kind of things. But then I found another method that gave us some results, which can be the cause behind this. So this comes under predictive analytics. Now, regression. We talked about regression as a predictive analytic tool, right? Regression is also a diagnostic analytic tool, right? If you can use the regression equation, then it becomes a predictive analytic tool. But if you use regression for understanding the past, then it becomes a diagnostic analytic tool. Does that make any sense?
Not clear.
Okay. What do you do in regression? Regression, you cannot use regression for forecasting. Why? You studied it. We call it exploration. No, what we call it? No, exploration is spelling, not exploration is spelling. We call it, for example, your regression model works only within the model. You cannot extrapolate it. You cannot extrapolate it, right? it only works within that model. For example, in regression model, if you are calculating from a value, we have it, we'll look into it a bit later. So I did regression here. So for example, you are comparing cells with, here we have compared cells with production time, right? So suppose your sales value is from 100 to 200 in different months, and you did a regression between 100 and 200. So tomorrow you have a sales value of 210. You cannot use that regression equation to calculate based on 210. You cannot. Regression equation only works between 100 and 200. Will work. Beyond it, it won't work. You cannot extrapolate regression. Okay? Is that clear? Because we don't know after that point if it can be curved, it can be something else. We don't know. So we cannot use that regression formula to extrapolate. Okay. So what do? Regression is basically also, this is why regression also works in a diagnostic tool, because it works within the framework of this historical data. Okay. So predictive analytics to predict what is likely to happen. So far what we have found out, we tried to find out what has happened. What has happened? Our sales order is decreasing. Why it has happened, we haven't found out yet. Because the hypothesis testing you did, it didn't provide us any results. It told us there's no relationships, right? So we'll see that if it is can find a relationship using regression model. A regression model was both predictive and diagnostic. Okay. If we do not change anything. So let's look into this. So regression model, there are predictive analytics, there are two kind of systems we use. One is regression based models and another one is machine learning models. Right? So we are not going to discuss the machine learning model obviously, but the machine learning models we use are MLP, multilayer, neural networks, radial basis function, support vector machine. I don't know much about this. I have done this, but I don't know much about this so far. Okay, machine learning is basically we do it when you have a big data environment. Okay. So to do this, understanding this, we need to have those environments and things like that. So I don't know much about this. Now this is something we all do. You have done all this, right? Regression trees. Have you seen? CART. C-A-R-T. CART. Okay. So regression trees are basically we call it CART. And we have time series forecasting. So you haven't seen CART, regression trees, the decision trees, and you haven't seen probably multivariate mass adaptive regression, which is fine, right? So these things are new to you, but other two things we have covered. So predictive analytics tools, we use this kind of tools mostly. So let's do a regression right now, okay? What did I did? I did regression of average delivery time, okay, and production time. So what is one of the issues we are finding? What is that? There was sales order decreasing, and they were telling me that it is decreasing due to average delivery time. Okay. So I am trying to see is the average delivery time is related to our production time or not. So I put the data, average delivery time of particular order, and what was the production time of the order, and what did I find out? I find out first thing p-value 0.00. Which means yes, there is a relationship. There is a very good relationship. Why? Because RS score is 94%. So there is a very strong relationship between average delivery time and production time. And regression equation is 5.03. Average delivery time is 5.03 plus 1.36 into production time. So now from this I can create the regression model within that. Right? So I can predict what can be the estimated time of average delivery when production time is something, right? But within that model, not outside that model. Within that data range, we can do that. Okay. So now we have one of the root cause. Identify one of the root cause, right? What is the root cause? Average production time. Average production time is very high. So now we also need to go back and to see why average production time is high. We haven't found the root cause yet. Average production time is why. So what? Why? Is it because of our production forecasting is not correct? Is it because our production planning is not correct? Is it because we have less capacity? Why? I don't know. But now again I have to go back and find out why my average production time is high. But now production team cannot say that this delay is not for me. The delay is for the average production time. Now we have to find out why again. Okay. Suppose we have found out something and that is our root cause. And suppose the root cause is that our capacity is low, right? Or we are running in only 2 shifts when we can run in 3 shifts. Things like that. Or we have less manpower. So there may be many different root causes you can also validate from data. Okay. So regression you can also use for prediction and also can use for diagnostic analytics. So some predictive model solutions, when the data number is limited, you can use Excel. In Excel you can do regression can do everything. Okay, most of the functions you can do in other softwares, you can do it in Excel. But if the data is more, I will suggest you to use Minitab. Minitab or SPSS, these are 2 very good software for statistical analysis. I personally prefer Minitab more than SPSS, but it is personal preference. Others may have different preference. You can also use RStudio. Okay, RStudio generally people use for big data, but RStudio is basically open source software. You have to learn some basic level of syntaxing, not even programming, syntaxing, I mean just giving commands. Remember, you guys probably haven't used it. Probably Bashar Shahab and others, some other older people like me have used it. DOS PC, MS DOS, or you have to write commands. Okay, before the GUI, you have this DOS PC, you have to write commands to get information. So it is something like that. You have to write commands to get graphs and data and other things, something like that. RStudio, but this is open source. This is very powerful, very powerful tool. You can use RStudios, and if you are into big data, thinking about it, you need to learn Python. Python learning is a must for you. If you are trying to get completely out of this accounting roles and completely into big data, go and learn R and Python. This two is must for you. Okay. And for the big data analysis, you use RStudio, Sisense, and Orphan Methodologies, and there are other tools also. Personally, my favorite tools are here. Excel is always there. Minitab is my favorite. SPM I have just started using. Oracle Crystal Ball is a magic tool. For scenario analysis, for simulation, it is a magic tool. It is a very expensive tool, but if you can have it some other version, free version, it's a very good tool you can use. For simulation, for example, you do forecastings, you do budgeting, you do other things. Use Oracle Crystal Ball is a fantastic tool for those kind of things. Okay? RStudio is fantastic, very good for data analysis, but if you use Minitab, you won't find RStudio very good unless you're working with big data. Okay, because for limited functions that you will be working on, Minitab is good enough.
Should we have a break for now?
I think we will have a break in 15 minutes or 15 minutes. Huh? We'll go to the namaz together, all together.
Yeah, very good. Together.
Just 15 minutes. We will go to the namaz together. I think the question answer sessions are mostly done in the through the presentation. So we have.
There's just one or 2 questions.
So machine learning. These are the theoretical discussions we want to do today. So machine learning, we have 2 things. One is supervised and another one is unsupervised. So we work in 2 ways. For example, suppose we are in this room, right? We are all in this room. You want to classify us, or you want to do a machine learning programming on us. So first thing, what a machine should be looking to do, they should be looking to trying to segregate us, right? For identification, they have to machine. We're talking about machine, not people. Machine should be able to differentiate us based on some criteria. So these are different criteria. When it's supervised means we have some idea about the people. For example, we know people here in this room are probably between age 25 to 45, right? Probably. So we have some idea about the people. We know these people are all SSA members. So we have some pre-category ideas, right? So then we are going to use supervised one. And then we'll try to either classify them or do regression them and try to get some information about them. Okay? So that I can, later I can predict who is that guy. Okay? Unsupervised means I know nothing about them. So if I go to the road now and see, or if I go to a crowd in a fair and see 100 people or 200 people, actually don't know anything about it, right? Them, right? So then you will use unsupervised method. How we are going to use it? We are going to use clustering. How we are going to use clustering? For example, in the fair, a group of people are focusing on the bookshop. So we can cluster them. These are bookshop people. Another group of people are focusing on toys shop. So you can cluster them, the toy shop people. Machine somehow has to classify you. Somehow has to make groups of you. Okay, you have to group you before going to you level or understanding you. So machine will do it in that way. So based on some information they will try to find the similarities they see between you and clustering together. So people who are going to the bookshops are similar because they love books. People are going to the toy shops are similar because they love toys. People are going to the food shops are similar because they are fat. Okay. And then you have associations. Associations means how we can look into that other ways also. For example, people will bear. We can classify in that way. Okay, association because they are sharing some kind of same association. Probably the Muslims. Okay, or people with gender. We can also do association, those kinds of things. So we can either clustering, association, classify, regression, and also in here we use dimension reduction. This is basically generalization. We try to eliminate. Here we try to find similarities. Here we basically find dissimilarities between them. Okay. So how machine learning works? Unsupervised and supervised and other information. What are these other information? Can someone tell? Other information? For example, there is the session is here in Dhaka, right? So though I have no way of knowing it, but probably all of you have come from Dhaka, right? This is not supervised, this is not unsupervised, but this is some new information I can use. Probably all of you have come from Dhaka. So I can go back and try to make some association about you. Since you have done SSCA and you are all working, probably you have a good job and good income. Right? These are probabilistic decisions I can take as a new data. So I can also feed in to the system as well. Right? And then I try to find feature extraction. What are the dissimilarities and similarities? So when machine learning, talk about machine learning, talk about big data, talk about segmentation, it's all about finding similarities in groups of people and dissimilarities in groups of people. Till I go to your level. Absolutely your level, right? So probably there is another someone like you somewhere. Okay, not facially, but your behavior pattern, everything, someone matches you. From that, I can predict you what you are going to do. Right? So I have machine, when machine learns that, a machine has 1,000 criteria, and machine checks those 1,000 criteria and saw that those fitting those 1,000 criteria, this gentleman loves pizza, then probably other gentleman who has fit those 1,000 criteria may also like pizza. This is how machine learning works. So machine learning tries to generate those algorithms. So algorithms, they group people, group objects of people, and they predict model what they're gonna do. Okay? So machine learning is all about many information, many data feeding in all the time. Whatever we see in Googles and other things and predictive analytics and things like that, these are mostly based on machine learning, so those kind of stuff, advanced stuff. Okay? So machine learning, there are some learning solutions and tools. Google has TensorFlow, Nirvana, Amazon Web Services, the world's probably best machine learning tool. Okay. OpenNN and Apache is for. Last one is prescriptive analysis. We are gonna just take 5 minutes right now. Okay? So prescriptive analytics, basically for us, as an organization or in Bangladesh, most of you who are accounting professional, the first two parts are good enough. Understanding descriptive, understanding diagnostic, and understanding predictive partial. Those are basically good enough, unless you are very fascinated about big data and want to work with big data. Then you can think of prescriptive learning and machine learning, prescriptive analytics and machine learning. But for others, those three parts are good enough. So prescriptive learning is a machine learning, I know what is happening, right? But he likes pizza. There is prescriptive learning. So how the machine is going to use it? Machine is going to tell him, Mr. What's the name?
Ali.
Mr. Ali, we have a good pizza offer right now. It's just 2 kilometers away from you, 1 kilometer away from you. There's an Uber right now near in the vicinity. If you want, I can order you him, or you can go there, or I can order the shop directly to send you your favorite Hawaiian pizza. That is prescriptive analytics. So they are not stopping at predictive. They know so much about you from unsupervised, and new data. This new data is basically data that they already have about you. Okay. So based on that, so much information you that they can prescribe you what is best for you right now. It's not something you said. It's not something you have told him to do. But in other words, it's not doing. It's not the SMS our companies say. Right? We all get buy one get one free, blah blah. It's not like that. It's highly targeted marketing. It's completely different. So what is happening? They're reducing the cost of marketing considerably. And also, they're giving you things that you like. They're not bothering you with other stuff. They're not bothering you with pop music. You don't like pop music. They're not bothering you with the pop music. They are not bothering you with a Nirvana concert in Bangkok, right? Because you don't like music. They know it, but they are bothering you with the good food festival in Bangkok, right? So this is extremely targeted marketing. We are not there yet. In Bangladesh, we are far from there. Some companies are trying to do that. Telecom companies are trying to do that to achieve those level or to go somewhere close to that. Some other local companies are trying to do that. Facebook tries to do that a lot with us. Google tries to do this, but Google mostly tries to do it with your last interactions, based on last interaction, things like that. Google has your at least 3 years data with them. They have saved it, and they analyze it, and they send you information about it, all the data they have about you. So these are the things that's gonna change the way people do business in the future. This is why prescriptive learning is so important. If system can directly prescribe you what to do and how to do, why we will need so many? Right? Why do you need marketing? Why do you need others? Because system knows. System can suggest you, tell you. Okay. We also do, fortunately, we also do some kind of prescriptive analytics in Six Sigma also. These are statistical level, other things. One is design of experiments. In engineers say, no engineers, I should have asked. But this is something a tool engineers use or learn to use. Design of experiment means, suppose I am trying to make this mobile, right? Okay, this mobile. So when you are working on this mobile, one of the functions is durability, don't drop. But durability also comes with flexibility. So if it is flexible, it's not durable. If it is durable, it's not flexible. Right? So I have to find the trade-off point where I can set it in the most optimized way, which will ensure that it is durable and it is flexible. So by design of experiment, we find this kind of solutions. Right? Design of experiments also used in marketing, but in different name. In marketing, we call it conjoint analysis. Okay, the same thing, same principle. The marketing people in organization, they will tell you about we are doing conjoint analysis. Basically, they are doing viewing. Okay, and RSM is response surface model. It's also similar optimization technique. What is the how we can, if we change other variables. How should we change other variables that we can achieve the optimum results? Most optimum results. We can use that. Simulation I have already talked about. A simulation can be used in many functions, also in prescription point of view. For example, I was doing a consultancy for an organization, and they're doing a factory, establishing a factory. So they asked me to do this simulation. So in simulation, when I found out that their model and their whatever the revenue are looking, I went back. I told them that you have 25%. There's 23% probability that you will achieve it. Just like why? Why 23%? Why not 25%? Why not 20%? So I showed them the solution results. So I'm not saying it. I have done it 1 million times in the system. I have run your concept. I have run your price models. I have put your assumptions. I put the right distributions. Things we make mistakes with simulations that we do is that we don't put the right distribution. Do you select the right distribution? What is distribution? For example, you are not selecting. There are many kind of distribution. For example, normal distribution, Poisson distribution, binomial distribution, right? Hyperbolic distribution. There are many kind of distributions. Sales is not normal distribution. So if you put the sales figure and just treat it as a normal distribution, it will be wrong. Your analysis will show you wrong result. So you have to find out what kind of data is what kind of distribution. You have to identify that. Then you have to put in the simulator. Then you have to simulate it. Generally, the way we do analysis, we don't do that. So that's why there's a major reason why our forecast is so different. Maybe in one class we have one session on this or something like that. How to use simulation or something like that. And I think can be helpful for all of you professionals. But how is the right way to do simulations? Okay, maybe in one class we can do that. Then the simulation should be much more accurate and things like that. So simulation is very powerful tool. We can use also in prescriptive analytics. And machine learning is always there. Prescriptive analysis, AI is there. Why AI is there? Artificial intelligence, why it is there? AI is a bit different. AI is not actually about only about machine learning. AI is about behavior patterns. Okay, it's not about if it is yes or no or something like that. AI try to analyze your moods, temperature, everything, and try to find out what is the best possible cause of this and things like that. Okay, heuristics is something another thing we don't look into very often. What is heuristics? Heuristics is or meta heuristics, we often call it. It is something like you put in some data and you don't go for perfection, but rather you generate a solution. Okay. So we can work all the day to find the optimized result, or we can find 7 or 8 potential results and we can give it to the customers. Okay. That is heuristics or meta heuristics. That we will do this. This is a simple way to explain it. This is very much more complex. But simple way to explain heuristics or meta heuristics is that it's not all about optimization, but it's not all about perfection, but it's about giving you quick but probably accurate results, but not actually it's not the best results. Okay, heuristics. So this is fast. When you do the heuristics, they also consider the heuristics also. For example, in his case analysis, they find out that he likes pizza. So to identify he likes pizza, probably they need another 30 data points, but they don't have it. So what do they do? They have to use those 70 data points they have, and they find out that he may either like pizza, or he may like chicken, fried chicken, or he may like burger. Right? Identify it, and then send him a address of a place or suggestion of a place which have all three. So they are not optimizing it, but still they are doing it to the sum level, going to the sum level to fine tune it for you, right? So they are not telling him to go to the Pizza Hut, but probably some place which have descent all three of them, so that he can go and eat. Okay, so this is also heuristics. It's not perfection, but it gives you options, or gives you is close to them, but it's not the optimized one. Question? Any question? Okay, we're almost done. So basically, What happens is this in predictive analytics, everything is done automated in automation. There's no human involvement here. You just put in the data, they collect data and things like that. You just set the algorithms, and everything is done automatically. In ideal prescriptive scenario, IBM has a bunch of tools. I have just visited IBM website last few days. There are many tools of prescriptive analytics of different functions. You can check them out. Amazon Web Services is also prescriptive analytics. NG Data is another independent one, small one, but a very good software. So far, what happened? So far, we have discussed the summarize. Do you have any questions? If you summarize, I know all of you is very tired.
There are a few questions. Should we go for the?
Okay, let me just summarize and we'll do. We have identified what's data analytics. We have discussed that. We have find out why data is important for, or data analytics is important for accounting professionals. We have talked about type of data analytics. What are the 4 types? First type descriptive that talks about what happened. Then we have the diagnostic that talked about why it happened. Then we had predictive that talks about how likely is it to happen in the future. And then we talked about prescriptive, that what we should do if it happens in the future. Okay, prescriptive is almost a new science or new area for us so far in Bangladesh people. So we're still learning it. We're not very much into it for Asian countries, but some functions we are using it so far. Big companies are using it. Okay, and then we also talked about those data visualizations. We have looked into that. We also looked into some of the samples of hypothesis testing and other functions and tools and techniques. So I think that's it. Any more questions?
There are a few. Should we go for a break or?
Yeah, I think we can go for a break. Or, okay. Come back and then we can. Will they wait?
Yeah, I'll just write.
I think it's how long? How many questions we have?
Not much.
No, but do you have to?
15.
Yes. I'll last back in 2016.
Yeah. So yeah, exactly.
Okay, everyone, can we please take the seats? Are they ready, Nurul?
Yeah. Should we start?
Let's start with the main questions first.
Okay. There was one question from Muhammad Ahmad Khan. He asked, being SSCI members, kindly let me know tools and techniques to gain data analytics skills and how to determine that the gained skills are sufficient and I should put a cutoff at gaining further skills and how to sell those skills to employer.
Okay, so I think he has 3 questions, right?
Yeah.
First thing is that I cannot tell you about any skill cutoff when to stop because industry is changing and things are changing so rapidly right now. I cannot tell you. I don't have the answer for that. When you can cut off learning right now at these times. The second question is first question was.
Let me know tools and techniques to gain data analytics.
Data analytics from the start or to begin with, you can start with learning Lean or Six Sigma, this kind of tools because it gives you a structured approach of understanding data analytics that you can apply in your daily, in your official or life, in your office and those, in work. You can apply those which can benefit both you and your office. But that's start. To be a data scientist, so data analyst and data scientist are different, right? So to be a data scientist, if you want to be work with data throughout your life, you need to be a data scientist. So to do data scientist, you need to learn those relative programming languages and working with relative tools. But it depends on your what is your interest areas. If machine learning interests you, that you can go out for that. If AI interests you, then that's a different discipline altogether. And if you want to combine and compile and work with those, there are options for that also. So it will depend on your preference, on your likings and dislikings. And the last question is
how to sell those skills to employer.
Well, to sell data analytics skill is very easy. The way I sell it, for example, from SSMI, when we go to the clients, we just simply tell you that whatever you have invested in your trainings and things, we are going to return at least 10 or 20 times of that within 1 year. That's very easy sell. For the companies, it's a very easy sell. This is one training where you can get the benefit very easily. So you can train, you can go to organization back, you can do the project, and you can earn the organization money. The organization can invest on it very easily. So data analytics will give the organization that kind of flexibility to invest in you and get quick return within a year and meaningful return. So it's kind of like a business for organizations also. I hope those answers your question, Mr. Ahmed Khan, right?
Yeah.
Okay, thank you.
Okay, there's another question. The Blue Prism software, is that related to prescriptive analytics?
Blue Prism software is more related to predictive analytics and it basically works more with, as far as I know, I haven't used it more at all basically, but what I've learned or studied about it, it works with AI and cognitive. So it basically works with your cognitive knowledge and things like that, your behavior, and it tries to work with artificial intelligence as well. Does it work with prescriptive analytics? I'm not so sure. I have to check.
That's all.
Okay, this true. Any questions from you? No questions? These online people are asking so many questions. You guys are asking no questions. Come on. Hungry? Tired?
They should actually, I think everyone should think about your workplace. Try to think a practical scenario where you struggle for decision. Then think about that area. There are a lot of industry representing over here, isn't it? Service, FMCG, and consulting, lot of areas. So think about, someone can think about any practical scenario where you struggle for any suggestion or advices, and given some hypothetical data, you can come up with some sort of uh, question in place where Sadiq can answer.
Okay? No questions.
No more questions.
So they are understood. Yeah.
How can we use Six Sigma for process audit?
Process audit?
Yeah.
Process audit is a different function. You don't, CCM is a problem solving and decision making tool. Audit is basically a checking tool, quality control. So audit is a part of Six Sigma control phase. But you cannot do, but if you want to.
If there is a problem in the process,
Yeah.
we can analyze the problem.
Exactly. So for example, in audit, you can find some problems in the process. You find that delivery is not going in the right time or things like that. And if you don't know the root cause of that, only then you do Six Sigma. If you know the root cause, why it is happening, why do you do Six Sigma? Six Sigma you only do when you don't know the cause, root cause.
Okay, there was another question. Any certification on data analytics from Six Sigma?
SSMI, we haven't offered any certificate data analysis yet, but we are planning for it. Maybe in few months we'll have it. Anything else? Okay. What is the Ramadan timing there? Is the timing in Pakistan?
I think they're 1 hour.
Okay.
Yeah, something 1 hour. So I think we can end the session and
Sure. Okay. Thank you very much, everyone, for coming and bearing with me for 3 hours, almost 3 hours right now. I hope that you have learned something at least and will take back something. But my only 2 cents will be, think about this, how you can use data in your daily life and as well as in your professional life. Because end of the day, things are becoming all about the data all of a sudden. So wherever you see, you will see people are collecting data, people are working with data. And just here, a minute ago, this brother was telling me that someone is capturing pictures or told the retailers to capture their daily shop pictures 3 or 4 times every day and send it to him. So from that, that person is using AI and to identify their shop shelf item product movement and analyzing those. So things are changing. Things are changing very rapidly and it's very fast. It's very scary. Basically, personally, I feel it's very scary the way things are changing in the industry. I've told you, I was a communication guy, but I moved to the data field. Data field, working in this area for a long time right now. Now I'm moving to more of a. I was in Six Sigma field, and now I'm moving to Six Sigma data field, working in these areas. So things are changing, and you also have to think about that also, how you are gonna, how it's gonna help. I have seen many people who are doing different kind of things that they used to do 5 years ago. In many corporation, in many professional life, I need also people. I am sure you know many people out there. Some people who are probably a director now. He is selling completely something else, software or something. Or some people are selling, I don't know, clothes and doing other kind of businesses. So things are changing. Jobs are not guaranteed anymore, like it was 10, 20 years ago. Careers are not guaranteed. Any career in Bangladesh is not guaranteed, or Bangladesh, Pakistan, in other places is not guaranteed anymore. Even if you look into the SSMI team, Shabat Bhai used to work in different place, Bashar Saib used to work in different place. I don't know about Nuriapur and you, but things are changing. So careers are, it's not about one career, one life. It's not about that. So you always need to learn, update, and look into ways how you can shift your careers for your betterment. Okay, so That is only my 2 cents from my learning of whatever learning I have for my few years of career experience. So that is something I need you all to think about. Whoever is career 4 or 5 years, 6 year careers, uh, you guys should think about what the future holds. I have shared you some of the slides, right? What the top skill requires in the future. What are the jobs people are looking into? What jobs will be available in the coming future? So how you can prepare yourself for those kind of stuff, for those kind of jobs, or those kind of skills is up to you. Completely up to you. So I have this fine another one. His brother is now learning his data, learning data. Someone I have here is learning Python already, working on Python already. Someone here is already working on AI. So things are changing. So better be ready before. You guys are forecasting experts, so forecast well. What is upcoming? What the future holds, and take decision. Do a prescriptive analytics and take decision accordingly. Okay. Thank you so much.
Uh, I would request you to please sit for a moment, please.